So thank you. My assignment from Mike, who is my senior at the U.S. Geological Survey, is to survey the earthquake and tsunami sources. And so there will be an attempt here to point to three generalized sources. And they're cartooned on this map, but I'll go to the next one to put a little more to them. So the one with the maximum magnitude of 9 is at the boundary between two tectonic plates, and you can see some of the generalized consequences of slip on that fault, and then another kind of earthquake would be the one that happens at shallow depth on faults that are right here in the kind of the inland waters areas. And then finally there would be a repeat of the Nisqually earthquake. So how many of us were here for Nisqually? Yeah. I was at SeaTac about to head to Japan, and a TV monitor nearly fell down, but I ended up getting in the plane and going to Japan. But anyways, it's those three kinds of earthquakes, and I've put a ballpark. You can get it at the bottom that some of these happen more often than others. So we'll get to that. We'll start with the big plate boundary earthquakes, and then we'll go to the other two. Okay, so on an upbeat note here, the New Yorker article wasn't quite as upbeat as it could have been, and it really, I mean, it didn't call attention to things like this that are being done. And a principal in this work is in this room is going to speak Cale Atch. I won't attempt to represent what Cale has done. And Tim Walsh can also speak to some of the background on this. But I'll still use this example. So this is a vertical evacuation structure funded with local money out at Westport, Washington. And here they are breaking ground. And the artist's conception at lower left, and then some of the initial construction over the summer. The setting is at right with the ocean in the foreground and Grace Harbor in the back. And there's a peninsula, sandy peninsula, that has the school site marked on it. And so they're replacing a grade school gymnasium with a structure that is to have room for as many as 1,000 people on the roof. So there's some lessons that are built into this. One, the obvious one for just getting out of a tsunami's way is high ground. But also, I've heard Cale present on this a little bit, and he mentioned, I think, that he went to Japan or used building performance in Japan in 2011. How did structures do well or do poorly in the tsunami in 2011, and they used some of that as guidance with the design of the structure. This painting is from a famous in Japan story that probably has something to do with the survival rate in Japan from the 2011 tsunami. It's estimated that 95% of the people in the areas that were wet from the tsunami that they survived. And the story here, you can see there are fires out in the water, and that's from rice straw that was lit by a village headman at night after the earthquake and before the tsunami came in to help guide people to high ground. And you can see the ant-like people going up towards the Shinto Shrine gate up at the top of the slide. But they're also built into the Acosta School there out at Westport some lessons from subduction zone earthquakes elsewhere. So subduction zones are these faults where usually it's an ocean floor is diving underneath the continent. And so here in Alaska, diving underneath the area of Anchorage is part of the Pacific Ocean floor. And so I graduated from high school in 1969, which is the year that the term plate tectonics first appears in scientific literature. This earthquake is 64, and the people who went up there investigated it. They didn't have the dogma of plate tectonics to work with. They didn't have subduction zone in their language. And they figured out that this earthquake was subduction in action. And in large part, it was because of the pattern of land level change expressed on shorelines as raised barnacle lines or as drowned spruce forests. So that gives you the raised area up in Prince William Sound extrapolated to the south under the ocean, and then inland to the southwest, Kodiak Island, and up towards Anchorage, Cook Inlet area, the land having dropped. And so that helped them figure out it was a gently inclined fault, and it led to the idea of subduction zones, or confirmed it in this fashion. But also for us here at Cascadia, where we don't have a 1964 earthquake in our written history, this provided some clues as to how you figure out whether you have this kind of earthquake in your past. And those clues are built into the design of the school. So you're familiar with this idea that if you have a coastal area has happened near Anchorage that drops 5 feet, that if you're a tree living dangerously close to tide level beforehand, you go for a swim afterwards, and the mud comes in and buries things, and you end up with these so-called ghost forests sitting out there. And this one at Copalis had quite a bit of trees back in the 80s when a geologist first started to work on it. Maybe 1/10 of those trees are still standing today. There's quite an attrition of the red cedar wood is finally failing, despite its durability. But there are red cedar ghost forests at all four big South Washington, all four Southwest Washington estuaries: Copalis, Grays Harbor, Willapa Bay, Columbia River. This one's in South Bend at Willapa Bay early this last month, and you can see that I am sinking over there is one of the trees that is drowned. But this kind of thing happens repeatedly along our Pacific coast. The lines in this creek bank at low tide, just as near Westport, are keyed at left to the approximate time when the land dropped, and each of those lines going across the bank is just differential erosion. The soil's more resistant to erosion, and there are buried forests and marsh soils, each representing abrupt lowering of land, and then the mud comes in on top and buries it, and you get this geological record. So here you have 3,000 years of earthquake history written at low tide in this bank. And you can see that the earthquakes happen at very regular intervals, so you can predict exactly when the next one will happen. But really, I mean, the average interval there is something like 500 years, but there are intervals as short as the time that has elapsed since our most recent one. And conversely, there are intervals several times longer. So you're not going to be able to predict it. Okay, so back to the school. So they have this topographic profile here. So 10 meters or 30 feet a height above high tide level, and then the topography of the Sand Ridge Plain out there shown going from west to east. And this group of tsunami modelers led by Frank Gonzalez made a simulation that I understand was used to help design the school. And the very first thing they did was to drop the land, as happened in Alaska and is evidenced by the ghost forest in southwest Washington. And then they brought the tsunami in. So the tsunami, of course, is being driven by the warping of the ocean floor that in turn is warping the ocean surface, and then things smooth out and the tsunami comes in. It's not the newspaper depiction of an epicenter and somehow the tsunami radiates from a pebble in the pond. It's the wholesale warping of the sea floor, and in comes the tsunami. This depiction at top shows the maximum height reached at any time during the tsunami. But the point is that the refuge was then designed to make sure that it was high enough so that it wouldn't get wet, even in the event of a magnitude 9 earthquake and an associated tsunami. So the green symbol there with the T-shaped thing, the top of the T, is meant to represent the position of the roof. Okay, so translating that to Port Townsend area, Tim prepared these some years ago. Tim Walsh did, and his coworkers. These are like little tide gauge records for simulated tsunamis, and they're a simulated tsunami, the same one, and they're holding the tide constant at a high tide level through the duration of the simulation for 8 hours. And the water level on each of the three rises, and there's a 3-meter scale or a 10-foot scale so you can get a sense of height. And I show this not to get into the issue of how high or how big. Tim and Carrie will get into this, but just to the point here that Port Townsend, the first positive wave, it comes in maybe 2 hours after the ground shaking. So, you think of the village headman who's burning his straw, rice straw, to guide people to high ground. They had a certain amount of time, not a lot, in that place in southwest Japan between the ground shaking. But here the natural warning of the earthquake is probably to be felt, and by this estimate, something better than 2 hours before the first big positive wave comes in. But there's another side of this, which is the locally generated tsunami from landslides. And you know that most of the deaths from associated with the 1964 Alaska earthquake were from locally, and so the tsunamis from local slides at all those towns and villages listed there at right, and keyed to the blue dots. And so it's easy to imagine that here also that there would be parts of the walls of Puget Sound that would fail and give you local slides that would come here real fast, where the tsunami would come much sooner than 2 hours. And then there's also the possibility of a delayed response. So that's something to keep in mind about the earthquake and tsunami hazard here. There are these compounding effects with these big subductions on earthquakes. In terms of how often they happen and how much gambling you kind of want to do on the odds, there have been some numbers bandied about how there's a 1 in 3 chance in the next 50 years. That's based on the estimates from deep sea work off of central and southern Oregon primarily. And this is really exciting and promising work. The findings haven't been replicated by other research groups yet, and it's a fairly complicated kind of recording system for earthquakes. So there will be these numbers may change with time, but in any case, at the southern Washington latitude, the estimate of 500 years looks fine with the creek bank that we looked at a bit ago out near Westport. But up at this latitude, it's not so clear. There are too many sand layers at a place that Carrie will take you to, Discovery Bay. And it's the open question as to which of these sand layers represent subduction thrust earthquakes and which represent some other kind of source. So stay tuned, I guess. Okay, so that's that source on the left. Now let's turn to the other two. And for that, we can partly get into the historical record. 2001, the source of the Nisqually earthquake, that area plotted down near Olympia, and then a similar one in 49, and nearby in 1965. And I think the current estimates of earthquake size for all these is something like magnitude 6.7 or something. And they're deep. They're like 50 or 60 kilometers, 30 miles down. in the subducted oceanic plate. It's a very strange source. So that's that kind of earthquake, and it's thought that an earthquake in the San Juans in 1909 was also from that kind of deep source. So for Port Townsend, it wouldn't be surprising from that standpoint to have that kind of earthquake source directly underneath us. Then there are earthquakes that are up in the overriding plate, and the 1872 earthquake over there, probably near Entiat, is an example, and apparently the 1946 Vancouver Island earthquake, which may be the largest of the bunch that's plotted here, current estimate is magnitude 7.5. So they have some consequences also for tsunamis, similar to the idea with the Alaskan example, where you get the shaking that sets off slides, and the slides make tsunamis. And there's quite a bit with 1946 up there, and including a fatality at this place called Deep Bay. And then many of you have seen this image from Tacoma Narrows, where a slide came down. Is it 3 days after, a couple days after the earthquake itself, that this weakened wall of Tacoma Narrows came down into the water and set off a tsunami. So, pretty much any of these earthquake sources, be it the plate boundary source or one of these deep earthquakes or a shallow or a crustal earthquake in here, any of these would be capable of doing this kind of thing. Okay, so that finally we'll turn to those shallow ones, and if we were talking 20 years ago, you could put up a map a little bit like this, but it would be quite a bit more conjectural. There's been a lot of geophysical work in the water bouncing kind of sound waves off the bottom and noticing layers that are displaced underneath the floor of Puget Sound. And then also laser topographic surveys that have identified scarps. And all this pretty much in the past 20 years has painted a very different picture than used to be for earthquake sources at Puget Sound. So nearly all of these faults have demonstrated evidence for earthquake, or at least for slip, in the past 100,000 or 200,000 years, and some of them quite a bit more recent. So the one that's most germane here is in the front yard, the southern Whidbey Island fault, and I think I had the question, the point of this slide is that there's evidence on two places along this fault zone for slip on the fault about 3,000 years ago. And the nearer one is from some shoreline studies, in effect, done at Crockett Lake and Lake Hancock over on Whidbey. And the idea is that the Hancock side went down 1 to 2 meters relative to Crockett Lake about 3,000 years. So that's the evidence right now for sort of young post-glacial movement on the southern Whidbey Island fault. Very impressive structure. And then the Seattle fault, that's responsible for, that's a pretty spectacular one. At the south side, on the south side of the fault, shorelines were raised about 20 feet during the earthquake, and that set off a tsunami in Puget Sound that washed over the sewage treatment plant site at West Point and into Cultus Bay, south end of Whidbey, and into the Snohomish River Delta, and over to Gorst, there near Bremerton. It's not clear whether it curled around into the Strait of Juan de Fuca, but it's easy to imagine that there would have been some tsunami felt up here at Port Townsend. So this is a real known actor with also one of these histories of very infrequent earthquakes. Thousands of years sometimes pass between successive ones that are known from the geological work. On the other hand, there are some examples with the Seattle fault of just centuries passing between back-to-back earthquakes on some strands. Well, okay, so that's the survey of these three sources. There used to be a Seattle Times editorial writer named Lance Dickey who spoke of having an unholy trinity of earthquake sources here. So this is the unholy trinity here in the Unitarian Church, and it's as you've seen, we have these big earthquakes on the plate boundary, and the duration of the shaking has to do with the size of the area of fault slip. It takes a finite amount of time for the fault to break, starting from the rupture starting point, and that gives you minutes worth of shaking. And the tsunamis are plural in the Alaskan sense because you have the open ocean tsunami, but at Puget Sound, almost certainly there would be local slide-generated tsunamis as well. So in that sense, multiple tsunamis. And I didn't mention aftershocks, but you've seen with Alaska, with the Japanese example, or 2010 in Chile, that they have quite a few aftershocks with these big plate boundary earthquakes, and that centuries on average elapse between them, but the intervals are irregular and are still under discussion. The next one over, the shallow ones, like the Southern Whidbey Island fault, the thousands of years on average between earthquakes on individual structures, and probably they would have lots of aftershocks, and tsunamis are likely, or in the case of the Seattle fault earthquake of 1,100 years ago, it's pretty well established. And then finally, a repeat of the 2001 Nisqually earthquake. That's the kind of thing for which buildings have long been designed around here since the 1949 earthquake, and it certainly wouldn't be surprised to see one of those. To go back to the upbeat side of things, I should call attention to this story. It's available online for free. You can download it. And it's a lovely little bilingual book, Japanese and U.S., in this case dealing with a boat that started out in one of the communities. It was a high school research vessel in Japan that came over as tsunami debris, ended up near Arcata, and high school students cleaned it up, and eventually ensued an exchange of students mediated in part by Carolyn Kennedy in Tokyo. But this is a wonderful story of sort of a positive side, in a way, despite the disaster in Japan. Thank you very much.